All right, radiation safety professionals, welcome. How sharp are your compliance instincts, really? We're about to find out with a little rapid fire quiz where, let's be honest, one wrong number can be the difference between a smooth inspection and a very uncomfortable phone call. Let's see how you do. You know that feeling, right? That pit in your stomach when a routine survey finds one little thing that turns into a big thing. Suddenly, you're the one explaining it all to a regulator. So let's run through 10 critical questions to make sure that day never comes. Keep your own score. You ready? Okay, question 1. Let's start with a fundamental. The ALARA Principle, as low as is reasonably achievable. It's the absolute bedrock of what we do. But where exactly is it written down in the Code of Federal Regulations? Take a look at your options. I'll give you 5 seconds. If you picked A, you nailed it. 10 CFR 20.1101. It's right there at the beginning of the section on radiation protection programs. And you know, they put it up front for a reason. It's the philosophy behind everything else. Okay, 1 down, 9 to go. Question 2. Now this is one of those numbers you should have basically tattooed on your brain. What's the annual total effective dose equivalent, the TEDI limit for an adult radiation worker in the US? Lock in your answer. You've got 5 seconds. And the answer is C, 5 rem, or 50 millisieverts, of course, if you're working in SI units. This number is the absolute cornerstone of managing occupational dose. Knowing it inside and out is just, well, it's non-negotiable. Okay, let's get a little more specific. We've done the whole body limit, but what about specific organs? What is the annual limit for the lens of the eye? Is it 5, 10, 15, or 50 rem? Go ahead and lock in your answer. The correct answer here is C, 15 rem. And you might ask, why is it higher than the whole body limit? Well, it all comes down to the different radiosensitivity of that tissue. It's a critical distinction to make in your program. And hey, check this out. This slide from the NRC's own guidance lays it all out perfectly. You can see the 5 rem TDE for the whole body, right next to the 15 rem for the lens of the eye, and the 50 rem for skin and extremities. This is a great little visual to keep handy. Okay, so we've covered the workers inside our controlled areas. Now what about everybody else? What is the annual dose limit for a member of the public from our operations? This number drives a ton of our environmental controls. Think carefully on this one. And the answer is B, 0.1 rem, also of course known as 100 millirem. It's just a tiny fraction of the occupational limit, and it's the number that really dictates our shielding design and how we control our boundaries to protect the public. Question 5 is so important. This is about our responsibility to protect the most sensitive among us. For a declared pregnant worker, what's the dose limit to the embryo or fetus over the entire pregnancy? The correct answer is C, 0.5 rem. And it's also really important to remember that the regulations say we should try to avoid big spikes in the monthly dose rate, right? It's all about meeting that limit smoothly over the whole gestation period. It's a key part of our duty of care. We're halfway through. Let's switch gears now from dose limits to area postings. At what dose rate does an area officially become a radiation area? Which means you've got to post it. What's that threshold? And there's your answer. An area becomes a radiation area when dose rates could be more than 5 millirem in 1 hour at 30 centimeters from the source. This is the first crucial line in the sand for posting and controlling an area. All right, let's level up. What about a high radiation area? Crossing this line changes the rules in a big way. So what's the trigger point for this one? That's right, it's C, 100 millirem per hour at 30 centimeters. And look, crossing this line isn't just about a different sign. This is where you need hard controls, things like interlocks or direct surveillance to physically prevent someone from just wandering in. So, we know the threshold for a radiation area. Now, what specifically does the sign have to say? What are the magic words required by the regulations? The answer is B, and the regulations are super specific about this. You gotta have the standard radiation symbol, the trefoil, and the exact words caution radiation area. No getting creative with it, no substitutions. It has to be just like that. Okay, question 9. Let's talk about personal dosimetry. Now, we often give badges out as a best practice, but at what point are we actually required by law to monitor our adult workers? What percentage of the annual limit makes it mandatory? The magic number is C, 10%. If a worker is likely to get more than 10% of any of their annual limits, dosimetry is no longer optional. It is absolutely mandatory. Last question, and this is a little crossover challenge for our colleagues working in the UK, or really anyone who deals with international standards. Under the IRR 17 regulations, what's the effective dose limit for workers?
And the answer is B, 20 millisieverts per year. Now think about that. That's less than half the US NRC's 50 millisievert or 5 rem limit. And this is a perfect example of why you have to know your local regulations. They are not the same everywhere.
So, how'd you do? Did you ace it? Hey, no matter your score, if you remember anything from today, let it be these 3 numbers. This is your compliance cheat sheet. Burn these into your memory. 5 rem for a worker, 0.1 rem for the public, and that 5 millirem per hour threshold for a radiation area. Knowing those cold will keep you on very solid ground. And that's a wrap on our quiz. You know, the biggest takeaway here is that OSHA is not the NRC, and the NRC is not the UK's HSE. The rules are different. Your license conditions and your local regulator, that is always your ultimate source of truth. Stay sharp, stay compliant, and stay safe. If you want to learn more about workplace safety and OSHA rules, subscribe to HSE Study.